Hey class, today we're going to go ahead and take a further look at some area applications using the quadratic formula, review some algebra that makes us battle ready and test ready. So this is Mr. Z. Let's go ahead and dive on in. All right, we're designing a bulletin board here. It has a width of 8x, a height of 2x. Notice how it's drawn out, hence why the visuals always help you. Sometimes you're given a diagram, sometimes you're not. But you could imagine, this is what you're thinking about. Each white piece has a width of 1 foot as shown below. Okay, we need to find the area of the shaded region, and you can imagine this is what's not going to be covered by the white piece. Now, you might be wondering what 8x and 2x means. I'm going to really challenge you to think in terms of the variable. Variable lets me test and put various inputs in. If I said x is 1, I'm just looking at the whole bulletin board. It would be an 8 by 2, which would have an area of 16. Of x is 2, it would be an input. 2 times 2 is 4. And likewise, 8 times 2 is 16. And this would go ahead and be 56. Notice the area increased when my input increased. This is literally the input. You plug it in, it changes. Really, what it means is that it is going to be longer than it is with the height. No matter how big it gets, it's always going to be longer. So, I need to find the area of just the shaded region. To do so, I have to know what I'm given. I'm given the total, the end game bulletin board. Now it's my job to enact this piece. So I'm going to take the area of the total and I'm going to punch out the pieces. So let's figure out what the shaded region is going to consist of. The area of the total minus the area, and we'll call it the white 1 minus the area of white 2 minus the area of white 3 and minus the area of white 4. The area of these pieces. So what we're going to do, this essentially represents in our brain the total is all of this space, and we're going to punch out rectangles going like so. Notice what's left over is the shaded region. So now I'm going to kind of clean this up and put this in terms of something I can actually use for this situation. To do so, it's important to remember that rectangles, opposites, are always going to be congruent. These white strips, I'm going to make them all the same size, so when I'm cutting it, I have less work. Also, opposites, congruent. It's a rectangle. I'm going to use that to my advantage. Now, all of these rectangles are going to be the same size. Notice, in each instance, 2x times 1 is going to result in 2x. 2x times 1, 2x. So I'm going to actually simplify this. Basically, it's going to be the area of my total, and I'm going to minus 4 area of the white rectangle. Well, let me go ahead and figure out each. The area of the total is going to be, so I'm going to use a of x. The reason being is this is how the boss wants it, is going to be equal to the area of the total. Well, the total is 8x times 2x. The area of the total, oops, let me just do it like this, minus 4, the area of the white region. Well, 2x times 1 is 2x. From here, I'm going to just have to clean this up, and it would end up being the area of x is equal to 16x squared minus, remember if it helps, solve it. Oh, then it's going to be minus 8x. And voila, I have a function to represent the area of the shaded region. Bada bing, bada boom. This complicated expression was cleaned up to be that way. Different equations representing the same situation. Think about which one your boss would want. So now the next request is, what is the maximum area of the shaded region if the maximum width of the shaded region is 20 feet? So zoom in here. The maximum width of the shaded region is 20 feet. The maximum width of the shaded region. So this portion, here, here, and here, the maximum width is equal to 20 feet. Well, what is that width? I know that the whole thing is 8x. And they cut out pieces that were 1, 1, 1, and 1. Okay, so what is left over? The shaded width is going to be equal to the whole minus the parts. The W is going to be equal to 8x minus 4. Clean it up. And now what are they telling me? The width is going to be 8x minus 4. 20 is equal to 8x minus 4. Pump the gas and start using inverse operations. I'm going to divide each side by 8, and then I'm going to flip it in my mind. Okay, x is 3. Almost there. So we found a expression to represent our width. We plugged in what our boss requested. Now we got to figure out how big does this bulletin board shaded region have to be. So A of 3, because that's what I just discovered, is going to be equal to 16 times 3 squared minus 8 times 3. What will the area of the shaded region be? Well, 16 times 9, and then 8 times 3 is 24. To do 16 times 9, I'm going to go ahead and break it up and treat it as 9 times 10 plus 6. 9 times 10 is 90. 9 times 6 is 54. 90 plus 54 is 144 minus 24. A of 3 is going to be equal to 144 minus 24 is going to be 120 feet squared. It's area, so it's going to be squared. All right, that was the bulletin board problem using the area of the shaded region.